All right, here we go, 7.1, hypothesis testing. So we're going to finish up the year by learning a little bit, not too much, about how to test a hypothesis. So when you're trying to test a hypothesis, what you do is you're trying to make a hypothesis on what happened with the population. So you have to take a sample of the population, and you have to decide if you're going to reject your hypothesis, which means you're going to throw out the hypothesis, or fail to reject the hypothesis, which means there's not enough info to reject your hypothesis. So let's say we're trying to figure out if a coin is fair. Real quick, we use p hat. P hat is called a statistic that goes along with p, which is your population parameter. And x bar is your statistic that goes with your mu. So p hat is like your proportion of your sample that you get, and you're trying to estimate the population sample. And x bar is the sample mean versus m is the population mean, right? So all of your hypothesis, which is what I'm going to teach you today, I'm going to teach you how to make a null and alternative hypothesis, are going to deal with the population parameters. P for proportion if we decide to use a proportion, and M for mean if we decide to use a mean. Okay? So you're trying to determine if a coin is fair. So your HO here is that P is going to equal 0.5. So if you have a sample, you should get heads or tails either 50% of the time. So P is the probability of getting a heads or a tails. Doesn't really matter. Alternative hypothesis, you have three different choices here. You could say P is less than 0.5. That's one. That's called a left tail. You could have P is greater than 0.5. That's called a right tail. And you could have P, here's your last one, P does not equal 0.5, and that's going to be a two-tail. So what you do is you make a normal curve, right? And we're not going to do any of the actual math behind it. I'm just going to teach you what goes in the middle. So this number always goes in the middle, so 0.5 will go in the middle. And then we have to decide, should our alternative hypothesis be P is less than 0.5, so that would be in the left tail. Or it could be P is greater than 0.5, that could be in the right tail. So you could have just the left, just the right, or you could have both at the same time. So if it's not equal to, that would be a two-tailed test. If it's either less than or greater than, that would be a one-tailed test. Cool. Okay, so let's do a couple examples here. AT&T claims that at least 90% of its users are satisfied. So what I would do is I would just draw my little curve here, and I would put 0.9 in the middle. Now, listen, notice that 0.9 is a proportion. So my null hypothesis, and it's always going to be the same, is going to be P equals 0.9. So we're going to say P equals 0.9. That means 90% of the people are satisfied. Now, if more than 90% of the people are satisfied, AT&T is good, right? But they want to test, or whoever is doing the study wants to test and see if less than 90%. So that's going to be over here. So this is in this little area here, that's going to be less than 90%, right? Because you could be a little bit less than 90%, and maybe you just got a bad sample, right? But there comes a certain point where if you get too far beyond, like, let's say 0.85%, or sorry, 0.85, 85%, or 0.75, or 0.65, when you get a certain distance away from the center, you're going to say, okay, this is probably not true, and we're going to go with the alternative. So here, this is going to be a one-tail. It's going to be P is less than 0.9. What tail is this? Is going to be a one-tail test. And it's going to be the left tail because we're looking less. So what happens if we if we run our test and we actually find our statistic, we get a p hat of like 0.65 or something like that. If we get something in this region, we're going to have to reject our null hypothesis for our alternative hypothesis, right? So if we reject it, we say we reject HO for HA, and say that less than 90% of people are satisfied. Now, if we don't, if we get something, if we run our test and we get like 0.85, or we get something in here or something in here, right, that's called not being statistically significant. What we're going to do is we're going to fail to reject, right? And when we fail to reject, we'd say fail to reject HO for HA, and say we do not have enough information to say that less than 90% of people are satisfied. Notice I did not accept HO. You never accept the null hypothesis. You just say we don't have enough information to reject the null hypothesis. Okay, let's do a couple more real quick. That's 4. Here's 2. Okay, the mean life of an iPhone is less than 4 hours. So what we need to do is we want to see if it's less than 4 hours. So we make our little curve here, a little visual, and 4 is going to go in the middle. Now from here you need to say, is it a proportion or is it a mean? So this is going to be a mean of 4 hours. So HOM equals 4. Now think about your iPhone. If you do your iPhone, are you going to take it back if your phone has more than 4 hours of battery life? Probably not. You're probably going to take it back if it has less than 4 hours. So you're going to say mu is less than 4. What tail? This is a one tail test. And it's the lower tail, right? It's under here. If you look at the picture, it's really obvious. So again, if you get anything inside of the shaded region, you're going to reject your null hypothesis. And if you get anything inside of the non-shaded region, you're going to fail to reject. So again, what would rejecting look like? Let's say I only got like 2 hours of battery life out of my phone. Well, I would reject HO for HA and say that there is enough information to say that less than 4 hours of battery life are on my iPhone, right? Fail to reject, again, we're going to fail to reject HO for HA. That would be something that happens in here. And I'd say there is not enough information to reject my null hypothesis, right? So again, you're not accepting this. You just don't have enough information to reject it. It's like when you're on trial. You're never going to be found innocent, right? You're going to be found not guilty. They don't have enough information to say that you totally didn't do it. They just know that they don't have enough information to say you're guilty. Okay. An auto battery manufacturer claims that the mean lifespan is not 74 months. So again, what you're going to do is you're going to draw your little curve here, right? 74 months will go in the middle. And this is going to be a mean because we're talking about lifespan here. It's not a proportion, so mean equals 74 months. Notice this is the null hypothesis is always going to be mu equals something. And then this one is actually going to be a two-tail test. Mu does not equal 74. So this is a two-tail. And the reason why I said that is because the lifespan is not 74 months, right? So it could be down here in this tail, or it could be up here in this tail, right? Reject. So if we reject, that means that we got maybe something down here in like the 68 range, or maybe I got something up here in like the 100 range, right? So I would reject HO for HA and say that there is enough information to say that the mu does not equal 74. And if I get something in here, I'm going to fail to reject HO for HA and say I don't have enough information to prove that mu does not equal 74. Again, we're not accepting the null hypothesis, we're just failing to reject. Here's a throwback for you. Q101 thinks that at least 39% of its listeners, it gets 39% of the listening public, right? So that means out of all the people listening to the radio, 39% are listening to Q101. Great station. We'll put 0.39 down here. So this is going to be a proportion. P equals 0.39. And this is a lot like the first one. So it wants at least 39. So If we get more than 39 people, that's going to be great. But if we get less than 39%, I misspoke here, it should be 39%. So anything in this tail is going to cause us to reject HO. Anything in the body here is going to cause us to fail to reject. So this is going to be P is less than, that's 0.39. This is a one tail. Reject wording. So again, if I get something in here, I'm going to reject this for this. I'm going to reject HO for HA and say that less than 39% of the population is listening to Q101. And fail to reject is going to happen when I get a p-value, a p-hat of maybe 0.4 or 0.5 or 0.7 or anything just in this non-shaded area in the body of the graph. And we'd say we fail to reject HO for HA, saying we don't have enough information to prove HA is true. Okay, so what we're going to do on Thursday and Friday of this week is I'm going to teach you how to come up with these numbers, how to know what number goes here, right? How to know kind of where that cutoff is. Is it 0.37? Is it 0.36? Is it 0.2? Right? How do we know where that cutoff is so that we can decide if we're going to reject or we're going to fail to reject? Okay? Cool. Try the Math Excel. Let me know how it goes. Peace.